Let's go to LeetCode 2817. Minimal absolute difference between elements with constraints. For this question, it gives us a list of integer nums and also an x. So it asks the x is minimal those kind of index are parts, right? So that means we need there are, if we have index I and j, they need to be at least x apart. So let's find the absolute difference between nums I and nums j to be minimal. So for example, we have a list here, right? So if nums I is from index 0, right? Then num j can only be from x, right? In the sense that if I, for example, equals 1, right? So num j from x to, it has a range to n minus 1, right? So be like this. If it's I is 1, should be x plus 1 to n minus 1, right? And until x goes to n minus x minus 1, right? And y I is going to n minus 1, right? So you see this kind of j range is keeping shrinking, right? Keeping smaller. So what we think about is that if we are able to first thing is that we may think about brute force, right? Brute force will be O(n) squared time complexity. And for the time range, it will be O TLE. But the thing is that if we are thinking, if we are able to keep this part ordered, right? And every time we iterate one index of I, we just need to remove one of the elements from this kind of data structure, right? So we just remove one index, right? And we need to still keep the ordering of this part, right? So what we think about is that if it is sorted, maybe we can do some binary search to find the closest one, right? But we can also use some kind of data structure to do this instead of the binary search. So what we think about is that we can use a tree map, right? Tree map. And the tree map, the things that they may have some kind of duplicate numbers in this data structure. For example, 2 appears multiple times, right? We think so that if we iterate, we remove one of the 2 out, we cannot move the key to directly from this kind of data structure. And we can only remove that when all the counts have been removed, right? So if we do the forward iteration, we have to use the tree map, and the value should be the counts. And for every number, we find it's the ceiling key and a floor key, and have the absolute difference as a candidate of final results, right? But the thing is that if we can do something better, improvement, right? Instead of we iterate I from 0 to n minus x minus 1, right? We can iterate I from n minus 1 minus x minus 1 to 0 in reverse direction, right? So I see for nums j, right? We have initial have nums n minus 1, then we'll add n minus 2, right? Until we add x, right? To add it to this data structure, we don't need to use a tree map because we are not removing. We just need to have a tree set, right? And for every number, it will have the floor and the CL function to find the closest one. And we have the absolute difference as a candidate for the final results. And we, in the end, we get the minimal for the absolute value, right? For the tree set, of course, sometimes we may not for this nums any nums I, we may, if we have the CL or flow, it's possible there is no such values, right? So what we think about is that we can put minus integer minimum or integer max to our tree set, right? So then so that we always have a floor or cell values to it, right? Then we can write a function, write our code. That's how int n equals nums dot size. And tree set, right? As we talk about, we can put integer max. And also the minimal to it, right? So that we'll always be able to get the flow or cell function, right? So we'll have int result equals integer dot max value, right? Then what we do is that for int I equals n minus 1, I greater equal to x, I minus minus, right? So what we do is that we know this kind of integer I, right? Nums I should be nums get I minus x, right? So on the left part, that kind of number, right? Left index, that number. So what we do is we should have add, right? Nums, the tree set, add nums get I. So we know it's for this num, right? This is actually the left index. Its flow is set flow function. No. And its ceiling is set ceiling. No, right? So what we do is our result should be mass.min result and mass.min. Should be num minus flow and still minus num, right? And then in the end, we just return result. Flow num. Output cell minus ceiling. The things that this kind of value, when we minus mean value, right, it may be out of range. So what we think about is that we should let's have this int r and f equals integer at max value. Let's shift right shift 1, right? Because this will be 10 to the power 9. So shift 2 may still not good, right? So let's do this one to be R and F, this to be minus IF, okay? The time complexity, right? So we'll say this kind of I, right? So that will be, we'll say it is n minus x. And for every tree set, this is a log operation, right? So that is n, so we'll say this n log, right? Log at most be n, right? So n log n time complexity, and it is linear, so it is I mean space, right? Space is linear. Let's write this to be Python code as well. Python code, if we want to use tree set, right, we need to import something called sorted dict from sorted containers, import sorted list. Okay. Then what we do is similar. N INF equals n equals length nonce, and INF let's set a float INF. Okay. And we are going to have sorted sorted list. We call this sorted list equals sorted list, and we are going to put INF and minus INF into it, right? And we have result equals INF as well, right? So for I in range n minus 1, we are going to have to x minus 1, right? Should in a reverse order. Then we'll have num equals nums I minus x. And a solid list, we should add nums, right? And we are going to use a bisetLeft function to get its get its cell. BisetLeft, that will be the smaller, right? So we'll have flow. Let's have index, right? Index equals sorted list bisetLeft. No. So we'll have flow will be sorted list index -1, right? And cell should be sorted list index. If index is smaller than length, sorted list, right? Else should be IF. And the result should be mean F result and num minus F and cell minus num. And in the end, we just return result. Bisect that.